Okay, thank you for joining us for another video here. We're going to be looking at using the factor theorem and the remainder theorem to solve this particular problem, and we'll have it be calculator active, so we'll see how we can use our calculator to help with us. Alright, so we have a polynomial. We know it's divisible by x minus 2. We know it has a remainder of 6 when divided by x plus 1. This happens to come from the higher level math paper from 2003 for the IB, if you're studying for the IB. You usually see these questions in Algebra 2 or pre-calculus type content. So if we know that this polynomial is divisible by x minus 2, right, we can think of it in the following way. Let's say that we let our polynomial represent a function f of x. So we could say f of x equals x cubed plus ax squared minus 3x plus b. Being divisible by x minus 2 means that f of 2, which would be 2 cubed plus a times 2 squared minus 3 times 2 plus b, we know that that's going to have to equal 0. All right, and if we know we have a remainder of 6 when divided by x plus 1, that means that f of negative 1 is going to be negative 1 cubed plus a times negative 1 squared minus 3 times negative 1 plus b. All right. So if I go ahead and evaluate for my first one, I have that 0 is going to be equal to 8 plus 4a minus 6 plus b. And for my second one, I'm going to have that 6 is equal to negative 1 plus a, let's see here, plus 4, it looks like, and, oh no, not plus 4, plus 3, negative 3 times negative 1 is 3, and then plus b. So once I have that system set up, I can come and use my calculator, go to equations to solve my system. All right, so I can say shift, let's not do shift first, right, that 0 is equal to, let's see, 8 minus 6 is 2, so that'll be 2 plus 4, let's go alpha a plus alpha b, so we have our first line, right, 0 is 2 plus 4a plus b, and for our second equation, we have 6 shift equal, right, negative 1 plus 3 is 2, so that'll be 2 plus alpha a plus alpha b. So we have our two equations, and we can come down, solve our equations. Oops, right, I want to solve the equation, and it'll give me my solutions in this case that says, hey, the solutions are a is equal to negative 2, and b is equal to 6. Right? That's with the calculator. What if it was non-calculator, right? If I had this as a non-calculator question, right, I could rewrite this, and let me go ahead and come back to what my original part was. And I could say, hey, that really is saying that 4a plus b is equal to negative 2, and that a plus b is equal to 4. And if I took, let's say, if I took this first row, let's say row 1 minus row 2, 4 minus a would be 3a, right? B minus b would be 0. Negative 2 minus 4 would be negative 6. So 3a is negative 6, which means a would have to be negative 2. And if a was negative 2, that'd mean that b would have to be equal to 6. So we could quickly solve this without a calculator as well. But it's nice to see that we can use our calculator, right, using the equation solver, type in our equations, and we can solve to get our solution in a fairly efficient manner. It's important that we know how to do the work without a calculator, but also knowing how to use technology is important for our courses in mathematics. All right. Thank you for your time. Please be sure you come back as you need some help.